Hello students, welcome back to my YouTube channel Mathematical Lens by Namita. In this video, we are going to continue with chapter number 3, Number Play of grade 6 Mathematics, Ganitha Prakash, the new NCERT textbook. In this chapter, we are going to talk about supercells. What are supercells? Right, so let us see. Here, you just see this table, observe these tables. So some numbers are not colored and some numbers are colored. Why is it so? So if you observe like 79 and see the neighbors, the adjacent numbers, 43 and 75. So 79 is greater than both 43 and 75. Means it is larger than the adjacent cells. If we see 29 is colored, it is larger than 10 and 28. 34 is colored because it is larger than one of its neighbor, right? Because there is no neighbor next to 34 on the right side, but this 28, it is greater than 28. So you can color this also, that's a supercell, right? 626, it is larger than 577, 345. Similarly, 790 is larger than 345, 694. And last number, 198 is larger than 109, right? So these cells which are colored, they are known as super cells, right? Now, based on this knowledge, we will try to solve the figure it out exercise which is given below. So let us see first one. Color or mark the supercells in the table below. So first, if we see, the first number is 6828 and its neighboring number is 670, right? So it is larger than, so we can mark this as supercell. 6828 is a supercell, correct? Now if we see 9435, it is greater than both the numbers 670 and 3780. So again it is a supercell. So you can color it or shade it. Then if we see this number 3780, it is larger than the right side number but not the left hand side number. So we'll leave this, It is already smaller. If we take 7308, it is smaller than 8000. Now if we see 8000, it is greater than 7308 and 5583. So we can mark 8000 also. So we got 3 supercells in question number 1, right? Now, question number 2, fill in the table below with only 4-digit numbers such that the supercells are exactly the colored cells, right? So here you have to make this a colored cell. To make this a colored cell, it should be greater than 5346, right? And here you have to take a number which is greater than less than the number which we have written over here, but it should also be less than 1258 because we want to make 1258 also a supercell, right? So it should be less than, first we choose a number here, so you can take 5400 also, no problem. Any number can be taken and it will be correct, right? It should be greater than 5346 and it should be less than 1258. So if we take suppose 1001, right? So this has become a supercell because both the neighbors are smaller than this 5400, and 1258 you want to make it a supercell. So we have taken 1000 here, we can take 1200, 1257, okay, because it should be smaller than 125. Whichever number you take, there are many possibilities in this case. Now, these none of them are supercells, right? So you can take different numbers over here. Suppose we have to suppose we take 1000, okay, then here we take 3256. You can take any number which is less than 9635 because if you take a larger number, then again it will become a supercell, and it's not colored, so it is not a supercell. Now last is colored, so you have to make it a supercell. So it should be greater than 9635. So we can take 9670. Any number greater than 9635. Okay. Now Question number 3. Fill in the table below such that we get as many supercells as possible. And we have to use numbers only between 100 and 1000 without repetition. So we can't repeat the numbers. So first thing, we can make the first and the last numbers as supercells. Right? So we try to take, because they have only one neighbor. Because we want our condition is as many supercells as possible. So if I take here, suppose 999, we take the largest possible. Here suppose we take 997, right? So here you have to take a number which is smaller than 997. So suppose we take 900, right? Now we want to make maximum supercells. So if we take, this is already a supercell, and we want to make another supercell here. So we take more than 900. So suppose 902. We take. So here we take a smaller number. Suppose 789. Right? So this has become a supercell. So we have got 3 supercells. Now we can't make this as a supercell. It can only be alternate numbers. So here, if we want a supercell, so suppose we take 800 over here. And if we want this to be a supercell, here the number should be less than that. So suppose we take 799. Okay. Now you want this as a supercell. So we take, suppose, 850. And here we take any number like, but it should be less than 850 because we want this as a supercell and this also as a supercell. So if we take, suppose 801, right? So now let us see how many supercells have we got. So if we put a tick mark, this is one supercell, this is another second one, then this is third one, this is fourth, and this is fifth. So we have got 5 supercells. So out of 9, how many supercells are there in the table? 5, right? So you can get 5 maximum supercells, means alternate numbers, and always consider the first and the last one and keep them as greater as possible, whatever the range of number is given, right? So this is answer number 4 also we got. Now there is a question here, question number 5. Find out how many supercells are possible for different number of cells. Do you notice any pattern? What is the method to fill in the table to get the maximum number of cells, and explore and share your strategy, right? So suppose we take 2 cells. I'll just show you here. 2 cells. So here only one possibility is there. Why? Because either this is supercell or the other one is supercell. Suppose we take 3. We are just trying to observe the pattern. So here what are the possibilities? You can make the first and the last one as supercell. So what is the possibility? Maximum 2. Suppose you take 4 supercells. 4 cells means, and then try to make maximum supercells in that. So in 4 also, either you take make the first and the last as supercell, or first and the third as supercell, not more than that. So answer will be 2 here again, right? So what is happening? It is repeating 1, 2, 2. Now if we see 5, we'll see till 5. So 1, 2, 3, we take one more. So here alternate, if we make supercells, so 1, 2, 3 are possible. Similarly for 6 also 3 are possible. So you can observe the pattern as 1, 2, 2, 3 and 3. Like this the pattern grows, right? Question number 6. Can you fill a supercell without repeating numbers such that there are no supercells, right? Is it possible? So, like suppose if we arrange all of them in ascending order, so that like 1, 2, 3, you will not get any supercell. But at the end, the last one, right? The greatest number will always be a supercell. Suppose I take the numbers 1, 2, 3, 4, 5, 6, till 6 I have taken. So all others are not supercell, but the last one, 6, is a supercell, right? So they have asked, no, answer is no. Can you fill a supercell table without repeating numbers such that there are no supercells? So it is, answer is no. Why? They have asked why or why not. Because like even if we write in ascending order, or descending order maybe. If you are writing in descending order, the first cell will be a supercell. And if you are writing ascending order, the last cell will be supercell. Supercell. Okay, this will be your answer. Okay. Now, next question is, will the cells having the largest number in table always be a supercell? Yes, because it is larger than all. So if we see the first answer, the answer is yes, as it is larger. Largest of all or greatest of all, right? Then another question is, can a cell having the smallest number in a table be a supercell? No, smallest can never be a supercell. So answer number 2 is no, as it is the smallest. For it to be a supercell, it has to be larger than the remaining, right? And it is smallest of all. So that's not possible. This is answer number 7. Now question number 8. Fill in the table such that the cells having the second largest number is not a supercell, right? So you don't want the second largest to not to be a supercell. So suppose we write the numbers in sequence. 1, 2, 3, 4, 5, 6, 7. Right, so you can see that this is the second largest number and it is not a supercell because this is 5 and this is 7. Right, so what care you have to take here? You can take any numbers here actually, but what care you should take that the one of the numbers, neighboring numbers of second largest number should be smaller, right? This is second largest, so keep the largest next to it. That is the most important part, right? So 7 is the largest out of that. Keep it neighboring to the second largest. So this will not be a supercell. Now here there is another question. Fill a table such that the cell having the second largest number is not a supercell. Second largest should not be a supercell, but second smallest should be a supercell. Is it possible? Let us see. So if we take the same numbers, these are 1, 2, 3, 4, 5, 6, 7. So which is the second largest here is 6 and second smallest is 2. Right, second smallest is 2. So what we want is second largest should not be a supercell. Okay, so we keep this. This was also not a supercell. So we keep that as it is, like we keep the same number here, 6, 7, 5. So second largest is not a supercell. But we want the second smallest to be a supercell. So what do? We keep it first. And write other numbers in sequence, right? So you can see the second smallest number, that is 2, is a supercell, right? And second largest number 6 is not a supercell, right? In question number 10, they have asked many variations of this puzzle. So like I have taken simple examples, 1-digit number. You can try with 2-digit, 3-digit numbers, right? And solve this puzzle and enjoy with it. Challenge yourself, challenge your partners, challenge your parents, and make such more puzzles. Now here there is an, till now we have done the supercell activity with one row, right? Now here there is a table, there are two tables rather, table 1 and table 2. The rule remains the same. A cell becomes a supercell if the number in it is greater than all the numbers in its neighboring cells, right? So neighboring cells means all the cells, like here in this case, all the neighboring cells. So like 8632, if you see, it is greater than 4795, 4580, 8280 and 1944, right? It is greater than all these four numbers. So then only it's a supercell. So that's the rule. Now there is a table 2. Complete the table 2 with 5-digit numbers whose digits are 10639. So we have to fill in this table in the order which I just explained for table number 1, right? The conditions are you have to use only these 5 digits, 10639. And only a colored cell should have a number greater than all its neighbors, right? So let us see. We start with the left hand most number column, that is the green color. So this is a supercell, so it has to be greater than 96,301. So there is only one possibility, actually 96,310. Now you want to make this as a supercell, so it should be greater than this and this. So suppose we take 36,910. Okay, this is one of the possibility. Then here this is not a supercell, so we write 36,690. Then here suppose we take 13,000, this is 13,690. Here we take 13,906. Suppose we take a number greater than this. Now you want to make 10,963 a supercell. So all the neighboring numbers in this 3 should be less than that. That care you have to take. So we take 10,000, suppose 639 we take, right? So it is less than this. Then here we take 10,369. Then here we take 10,936, suppose, because it will be smaller than 963. Okay, so this becomes a supercell. Now this is again a supercell, so it should be greater than these two numbers. So first we write down the number here, and it should be smaller number. So we take 19360. And the number which we are writing over here should be greater than both of them, right? So if we want a number which is greater than 19360, so suppose we take 93061, any number, right? Okay, it should be greater than these two. That is important. So you can even start with 3. You can start with 6, you can start with 9. Okay, so we have filled in the table and we have tried that all the numbers which are colored, they are supercells. Now based on that, there are some questions. We'll answer that. The biggest number in the table is, so if you can see, the biggest number is this cell, first cell, that is 96,310. Actually that's the biggest number with this 5 digits. So for everyone this answer will be C. First answer will be C. Other answers may vary for person to person, whatever numbers you have chosen. If we take the smallest even number in the table. Now if we say, see, smallest we want, so all are 10,000, 10,000, 10,000, we'll see those numbers. So these are 4 numbers which are starting from 10,000. We want an even number, so there is only one even number here. So that would be the smallest. So 10,936 is the smallest here. Now they have asked one more question. The smallest number greater than 50,000. Now greater than 50,000, but smallest, not the greatest. So there are only two possibilities in our case, 60,000, 60,000. So smallest out of these two is 60,193. So that would be your answer. So once you have filled in, they have asked us to put commas appropriately after the thousandth place, which we have already done, right? So we continue with this chapter in the next video. Thank you. Patterns on a number line. So patterns on a number of numbers on a number line. So we are quite familiar with the number lines now. So let us see if we can place some numbers in an appropriate position on the number line. So here are some numbers given: 2180, 2754, 1500, 3600, 9950. Okay, so many numbers are given. There are number line given. Now two numbers are already marked: 2180 and 2754. So we will mark the remaining numbers. So we start with 2180. So you can see 2180 is already marked. So we go with the third number. First two are already marked. So if we see 1500, now 1500 is exactly between 1000 and 2000. So this will be the position. Okay, 1500. Now 3600. So if we see 3600 is, if we take this as the center, then 3600 will be a little after the center. So here we can write 3600. Then 9950. 9950. 9950. It is just 50 less than 10,000. So it will be very near to 10,000. So we can write 9950 over here. Then 9590. So it will be somewhere in the middle, a little after that. So this is 9590, right? Because it is 9,500 will be exactly in the middle. So little bit near that. Now 1050. So now 1050 is very near to 1000. So we can write it here. We can mark it somewhere here. And we write it on the side, 1050. Now if we see 3050, so 3050 will be very near to 3000. So we write 3050. You can use scale and mark points. Then 5030, it will be nearer to 5000 because it is just 30 more than that. So 5030. Okay. Then 5300, it will be again a little before the center of 5000 and 6000. So it is 5300. And the last is 8400. So it will be again little before the mid of 8000 and 9000. So this is 8400, right? Now there is a figure it out exercise which is based on the same number line concept. So they have marked 2 points, and based on that you have to identify and mark the remaining points. So if you see here, this is 210, this is 220. So exactly in the middle will be 2015. Okay. Now based on that you can just reduce. There is a 5 difference. So what will be before 2010? It will be 2005. Here it will be exactly 2000. This is 5 less than that, right? So it will be 1995, and this is 1900. So you can see you are jumping 5. Okay. So after 2020 it would be 2025. This is 2030, and this is 2035. Okay. So first identify the pattern and fill in the remaining numbers. Now if we see question number B, there's only one difference, 9996 and this is 9997. So naturally, if we start from here, this is 9995, this is 9995, this is 9994, this is 9993. So if you write from the beginning, this is 9993, this is 9994, this is 9995. Right, so this will be naturally next number 9998. Here this will be 9999. This is going to be after 999, it would be a 5-digit number, so that is 10,000. There is less space, so I am writing the number above it. So this is going to be 10,001, and this I'll write below 10,002. This is 10,001. Question number C. Here, let us see the pattern. 15,077. This is 15,088. So next number will be 15,079. This is 15,080. Right? This is 15,081. I can write this number here, 15,082. This is 15,083. So next would be 15,084. This is 15,085. Very simple, they are just counting numbers. Then 15,086. Okay. Let us see the last pattern, the number line. This is like 86,705. This is 87,705. So what is changing here is the first two digits. This is 87, this is 86. So this would be 85, 84, 83. Right? You can even write it. If there is less space in the book also, you can write it standing. So first one would be 85, 84, 83. So this is 83,705. This last three digits will remain the same. This is 84,705. This is 85,705. This is 88,705. This is 89,705. Now what comes after 89? It is 90,000. So next would be 90,705. This would be 91,705. And this is 92,705. So there is a question at the end. Put a circle around the smallest number and a box around the largest number in each of the following sequence. So if you observe, they are all in increasing order, right? So naturally the first number will be the smallest. So just make a circle around it. I'll show you one. You can do the remaining. And the last number would be the largest of them. So you can make a box around it or a square around it, right? So we'll continue with this chapter in the next video. Thank you.